Welcome to the Hedgineer Podcast, with your host, Michael Watson.
Hedgineer.
Hey everyone, and welcome back to the Hedgineer Podcast, where we discuss AI, data, and technology for hedge funds, asset managers, prop trading, and interview the engineers and thought leaders that are building out those systems and share it with you. So today I'm excited about a guest that we have, Brian Lee. Used to work with him in a prior role, and he's been a thought leader, especially when it comes to UI, UX in the hedge fund space. Now you create intuitive tools and systems for portfolio managers, analysts, risk managers. Has recently spent time as a senior engineer at Figma, a world-class UI developer tool platform. I'm sure everyone's familiar with it. And so he's got a really unique perspective on the interplay between UI, UX, and asset management and hedge funds. So super excited to have him on the show. Would love you to walk through a little bit of your background from where you went from Citadel to Figma and what your career journey's been like so far.
Yeah. So I went to college for computer engineering. I was really interested in just like understanding how systems work from like a really fundamental level. So yeah, I got my starts over in software engineering, actually over at Intel, working on their FPGA compilers. So like this was very, very like low level stuff. Learned a lot about C++, learned a lot about just like how compute works over there. And I think just naturally it kind of expanded to me trying to understand more of the stack. Learning more about web technologies, web engineering. I did some backend internships over at just like large, like unicorn companies. And then, got into Citadel and worked for around 2 years over in equities on the entire UI application suite. So really, kind of my journey there has been all the way from the bottom of the stack, from bare metal, all the way up to UI. And then, I've been working over at Figma the last 2 years. And I really wanted to just be able to kind of work really at that layer of like interacting with users, product engineering, understanding the design process, and product thinking from one of the industry leaders. I've been doing that for the last 2 years. Yeah.
Awesome. And that's where we first met, was when you joined Citadel on the equity side, when I was running equities over there.
Yeah.
And I remember like chatting with you in one of our first one-on-ones, and you had taken so quickly to the UI side, which a lot of developers, when they come out of college and they start working at Citadel, they want to go low level or more pure stats or get really deep in more of the back-end engineering. And it was really rare to find somebody that loved the user interface of hedge fund asset management technology development. In our first couple of one-on-ones, we were chatting. I was like, hey, if you love this, there's such a world of opportunity in this space for you to grow. And so if you're into UI, just keep doubling down on it. And it's been awesome to see you do that, go from Citadel over to Figma. And I'm curious, like, what was that jump like? A lot of like engineers, they might start at like a big finance firm like a Citadel, Millennium, Bali. They all hire a bunch of engineers. And then sometimes you go and make the jump to more of the big tech space.
Yeah.
What was that like for you?
Yeah. I mean, so I guess first off, just saying, like starting over into UI, not a lot of engineers, a lot of my cohort didn't really want to do that. But for me, it was almost just like a very natural transition. It's like, I've already learned a lot on the engineering side of things, but there's just like this big unknown of like, how do users actually use our application? Mm-hmm. Like, what are we actually building for, our users, right? In this case, our analysts, our associates, our portfolio managers. And what better way to do that than actually working on the applications that they use every day? And so I think for me, making that decision to, like, as you said, like double down on UI engineering, UI platform was kind of almost just like a need to understand the business at like a fundamental level, and just kind of be there to, one, build out the actual tools, but two, just like understanding and learning from all of the different people in that space. So I feel like if you work in product engineering, if you're building out UIs, you have just so much more exposure to the kind of entire stack, as opposed to like if you're very down in the weeds, you might not even ever know like when a user is actually using what you've built out. And so in a similar level, I guess on a similar vein, actually, going from Citadel to Figma was just like kind of just like trying to grow that part of me. I think Citadel, we're creating applications for a small set of users, right? And that's like a very different challenge than creating an application that's being used by millions of different users. So there was kind of that need that I wanted to grow in. And so that was kind of clear to me that I need to make that switch eventually. So yeah, ultimately I did. Yeah.
Awesome. Really cool. And so that's an interesting dichotomy that you have between the two environments. Whereas at Figma, you're developing for tens of thousands, hundreds of thousands, millions of users, where within an asset manager like a Citadel, you're developing for dozens of users. And you would think that the impact would be significantly more if you're creating for the millions versus the dozens, but this is also an environment where those dozens of users, if they're really effective, could be making billions of dollars. And so the financial impact could be the same, but the way that you may approach the two problems could be different. So like, I'm kind of curious from your perspective, how do you approach UI development when you're dealing with the dozens of users versus the millions? And is there any like different perspective that you have between the two?
Yeah, for sure. I think in UI, you have kind of this concept of like archetypes and like trying to break down your user base and segment them into, different personas that each person might have. So, I mean, in the context of like hedge funds or asset management, like one breakdown could be things like, okay, am I building for an analyst? Am I building for an associate? Am I building for a portfolio manager? Am I building for investor relations? Am I building for someone who's more interested in risk management, right? And then similarly over even in Figma, we have different types of users, right? We have users who are completely new. We might have developers. We might have users who are veteran, designers that have used previous tools. And so I think the first approach that you need to do is like you need to obviously understand how you break down your users, right? And there's also something to be said, as you said, that even though you're building for a very small subset of users, it could be those users that provide the most impact to your company, right? And so you want to ensure that you are optimizing and building out flows that are tailored to those users, and not just like the happy path, right? So for example, like if you're building for, an analyst who's probably more interested in research, and like you need to build them tools in an application that's like very geared towards that. And these might be users who are actually using your tool all the time, right? But just focusing on these users might be a mistake, right? Let's say if you're more interested in portfolio management, right? Your tools are going to be very different, right? You probably want to understand deeper level, what are the different factors that are going into your model, into your portfolio. You want probably more different breakdowns of P&L. And these users could be using the app every day, but some portfolio managers might not be using your app every day, right? It might not be part of their core workflow. And so I think the only way to really understand this is to like really understand your space and then just go talk to some of these users, especially as the amount of users you have, as that gets smaller and smaller, each individual user has like a much bigger impact on obviously like what you're actually trying to build. Versus, when you're building for the millions, right? These are things like you can't interview, you can't talk directly to every single user, right? And so there's different strategies to get user feedback there, right? Through things like surveys, through things like Twitter, through things like different betas, right? So I think the strategies are very different depending on like who you're building for there.
Yeah, no, I think you're totally right, and the level of expectation that you have when you have a smaller user base from that user base is oftentimes that much higher. So
exactly,
if you are building a tool that is specifically designed for a equities long short research analyst, the functionality and the features that they just assume would be there because you're building a equity research tool for a long short analyst is going to be pretty feature rich from what they would assume would be there. And oftentimes what I've seen when you're trying to hire software engineers, technologists into the hedge fund asset management industry, that the gap between user expectations for basic functionality and the domain knowledge of what is required, especially for like a UI developer, there's just a huge gap there. because there's a lot about this domain when you have very niche, bespoke workflows, use cases, that it's really difficult for somebody just to come out of school and understand that quickly. And you honestly did an awesome job at it. So like kudos to you. And also kudos, like in the first part when you were kicking off of discussing, you had an innate interest in the business, not just the technology, but you want to understand ultimately this technology becomes an enabler for another set of products. And those are world-class risk-adjusted returns that you eventually sell to the investors in the fund. And you even touched on the investor relations component of that, which is very often a segment of a hedge fund employee base or like a set of stakeholders in an organization that most people don't build for. So like the fact that you were even touching on the role of investor relations as a archetype when building out UI UX, I think is a very nuanced way that I think for me, I guess I really appreciate it. What about like on the tech side? So how do you, like if you have to build out a technology platform, how do you think about like, I don't know, the interplay between front end and back end in the underlying data model and data structure? What are the tools that you find yourself using often and always coming back to?
Yeah. So I guess like first off, like typically, I sometimes don't even like the dichotomy of like front and back end because I think oftentimes, especially people who aren't as familiar with some of the complexity that comes with building like a very good front end and UI platform, kind of makes them think that they're very, very separate. But a lot of the issues that actually you run into when you're building a UI platform comes from not having a good data model in the first place. Mm-hmm. So things like just having APIs that don't really make sense for things that you want in the front end, right? So now you have to work around a kind of finicky API, take that data, mold it into something that works on the front end. But then as that starts to evolve, now you're doing like tons of different data fetches in the front end. Mm-hmm. You're fetching tons of data that you don't need to. Performance starts to slow down. So I think often a lot of the first things I always think about is trying to understand like just what is the actual data model, what are the different APIs needed first, and then working from there. Like if you need to create some new API endpoints, if you need to do something like WebSocket streaming into the front end, right? All of this comes from understanding what the data is first, and then you can build on all your different technologies to make the experience interactive. Yeah, I mean, as cliche as it sounds, it's always about the data.
Totally.
Right? And so focusing on that first, and then you can start introducing all these new technologies. You talked about different technologies. I think right now, obviously, React has actually taken over as the, de facto framework. The entire ecosystem is primarily driven by a lot of different different projects, as well as like if you're trying to find someone to develop a UI platform, all the jobs are in React. So I don't see React going away anytime soon. There are some issues architecturally with React that sometimes people like point out and try to find some different frameworks. And some of those issues are completely valid. But React, for what it is, does the job quite well. And there are ways around some of those issues. So yeah, React, I think, is here to stay. Mm-hmm. There's always almost kind of like a meme that there's always a new JavaScript framework that is created, every month, which is there is a lot of developments in the JavaScript ecosystem. But the reason that is because there's a lot of different challenges that are coming up. Mm-hmm. And these technologies are essentially a way to solve those problems or to solve the developer experience because of a lot of legacy systems, right? So I think one very interesting breakthrough that in the last, I guess, year really is that everyone is now jumping onto this thing called Tailwind CSS in terms of different CSS technologies. And this was like something that developers have been having issues with. CSS, when it was first created, was quite simple. It was made for just static web pages, and it was a great technology at its time. but it's been a very, very long time since those days. And now we're building very complex, web architectures with components, and really thinking more so on a component level. And so, movement towards these new technologies such as Tailwind CSS is more so the reason that's happening is because we don't structure our applications like we used to. Technology is changing. There is more expectation. There is more performance issues that we have in the UI that we didn't have before. Things like Next.js are popping up, which essentially is a framework around React, just to even show that React obviously solved the whole class of problems that developers were having. But even within the ecosystem of React, there's a lot of different issues that you need to think of, such as like app level routing, such as determining whether or not to do computations on server side versus client side. There's like just this whole journey of technologies that are constantly evolving as our need for performance, as well as different compute trade-offs that we have to think about evolve. I guess like one recent shift is moving a lot of our single page completely client-side applications, which were primarily being developed, over the last 5 years, shifting some of that compute over to the server side again. And it's almost like come full circle, right? In the beginning of web development, you just create a single page, you serve that, and then boom, you have it on the client. But then as we shifted over into more expectation being placed on these web applications, people were interacting with them, people were using them every single day. A lot of that computation and I guess compute has been now put over to the client side. But that runs into bottlenecks as well, right? So now we're going back over to server side and trying to essentially, we want to be able to do the computation where it makes sense. And a lot of like the I guess new technologies that are emerging in this space is due to challenges like these, right? We constantly do have these like evolving evolving constraints and challenges. And technologies are meant to solve those problems, right? Not just for the sake of having new technologies.
Totally. Have you looked at HTMX?
Yes.
At all?
Yes.
Because I think HTMX is like built directly in that vein where you want to have as much as much calculations or data models all done server side, and the server side does the entire rendering. But HTMX does a good job of just rendering the specific components of the DOM server side and then re-injecting that into the page and leaving the page as much vanilla HTML as possible. And it starts blurring the line between a back-end and a front-end developer in a really cool way. And I haven't actually built an HTMX app other than like the Hello World, but it's pretty cool how much it exposes to like a full stack developer to switch easily between front end and back end. Any thoughts on that?
I would first off recommend any engineer who wants to get into UI or UX or front end engineering. They should understand like end to end, right? They should do some full stack work to understand just like the entire pipeline of like how to actually get data to your front end. And that's why, again, like I know I touched on it before, I don't really like the dichotomy between front end and back end because often it kind of creates this divide that is unnecessary.
Totally.
UI engineers obviously need to understand where they're getting the data from. And if need be, they should be able to write, write those back-end services as well, depending on the size of your company, right? But I think just bridging that gap is just a natural extension of, one, the maturity of the technology landscape in front end, right? Again, breaking down that divide, like why do we have to do everything client side, right? And this wasn't a controversial thing back in the early days of the web, right? It was everything primarily was done on the server side, right? And so just getting out of that model that, hey, everything is simply just running client side, and understanding that, well, it's really up to you as the engineer to figure out where it makes sense to do that compute. And a lot of compute simply does make sense to do it in the back end, right? I still think that for the majority of the applications in the hedge fund space, they probably will have a lot of client-side code because there's a lot of interactivity in the sense of if you have real-time streaming of data, right? That's just simply not possible to do a lot of that on the back end and then sending that HTML to the client. There are different technologies that deal well with streaming data like that, but I still think that the way that a lot of these hedge funds and the way that I would implement this, things like streaming data would be a lot in client side.
Yep.
But things for like just static pages or just that are primarily static, a lot of this can be done server side, and we can also just do a lot of. It opens up a lot of possibilities. Like we can do computations that would be just impossible to do on the client side simply because they shouldn't have access to that data or just due to performance reasons, right? We can't guarantee that they're always going to be using a high-end machine to be using these applications. And so shifting that compute, especially like the heavy compute over onto server side just makes a lot of sense here. And I'm glad that the JavaScript ecosystem has finally kind of created solutions that make it easy for developers to do that.
One question that I have for you as somebody that's worked within Figma, and it's an awesome tool, we use it all the time, is how do we get from an awesome Figma mockup that looks incredible into a production application in as short as time as possible? Because there is still a non-trivial amount of work that needs to be done to go from mockup to application in production. And solving that problem and closing that time to product and time to delivery loop is a silver bullet. I haven't personally been able to crack the nut on that yet. What are your thoughts?
Yeah. So I think the first thing I would try to figure out is kind of, do you even have a process from design to code? Right. And this could be informal or this could be formal, right? It could also be more manual. It could also even be automated. Figma provides different levels of kind of, structure for you to be able to do that. Recently, there was a really big push for Figma's dev mode. So this is a initiative that Figma invested a lot of time in, simply targeted towards developers. So once you've created your designs, handling the design handoff to developers, there's a completely different kind of application that they can use that is specifically tailored for developers that peek into things that they're more interested in, such as like, what is the CSS that I need to do? What are the different kind of like component structures that I need to make? You can integrate it with a component library that you've made such that you can go directly from a design without designers having to do anything, and it will actually generate your component library in code. And so these are more of like the automated things that you can do. And obviously there's more of a process as well that you can work on to improve that workflow as well. And that process is like just having a good communication between your design team and engineering team. And what that means is like, one, does the engineering team understand the design system that you're trying to create, right? If they don't, then they're just bound to be a mismatch between what you design and what's out in production, right? And then there's so much thrash that you have, and then it just doesn't feel like smooth. And so any engineers working on a project should have that constant kind of feedback loop with their designers, and understand the design system and the constraints that they're working towards. So these are more process related things that you can do to speed up that efficiency. A thing that overarches and makes all of this easier right now is obviously, the very exciting developments in AI. And Figma has been making a lot of investments there over in AI just to make all of this easy. And so there's a lot of different tools that you can do to make this easier, and also just lower that barrier to entry for developers to use a tool as well. I think it's like very intimidating when you use Figma for the first time, especially if you're not a designer. So, these are where things like, Figma's, dev mode come in handy. Things like AI come in handy so that you can make that as seamless as possible. another thing too is that if you are not mature enough as a company to have developed your own in-house design system, you can reach into, some of these new technologies that have come out. For example, ShadCN is essentially it's a copy and pastable design system that you can use and that you can tweak and make into your own design system. And that will save you a lot of time, but you also get a highly polished and consistent design system that you can build on. And you're also not necessarily locked into an entire styling system and component library, such as things like Material UI, which have been used a lot in the past. So I think it really depends on the size of your company, right? I think there's a lot of different tools that you can use AI and you don't need to use AI. That can help you speed up that process. But it really is just I think there's a lot of friction between the designer and developer handoff. Mm-hmm. And so whether you use AI to do that or whether you use process to do that, both those need to be used to ultimately get the output that you want.
Totally. And I think that when we were chatting about this earlier, you highlighted for me hey, design doesn't start with Figma. That's maybe an intermediate toolgate, but the design starts with this, a conversation where you are talking to somebody about their problem and you're trying to better understand it just as a human being. And then you might start iterating on what are different ways that me as a software engineer and a developer can solve their problem with code, data, and more so AI. And then I might use Figma as a way to really quickly mock up that solution, get feedback on it. But Figma is one part of the design process that is not the first one. And remembering that, it was just a really interesting element that you reminded me of earlier. So with that, would love to think through where do you see AI going on the design side? How much, or when will I be able to tell a model what is the problem that I have, and it spits out the Figma mockups plus the automated then it just jumps to the automated CSS, the deployed React code with unit tests, and it just looks good. How far away from that?
Yeah, I mean, not going super into specifics or deadlines here, but I think the capabilities with the current iterations with LLMs are actually enough to do a lot of that process. And if you think about what one of the things that LLMs are good at, which is converting one structure, right? So for example, Figma, the document model within Figma, into another structure, such as HTML, or maybe it's your component library. That's actually a problem that LLMs are great at solving. Mm-hmm. Now the difficulty here is more so just in fine-tuning that model and making sure that it generates the right output most of the time. And the thing is, most of the time is actually good enough. If I can actually get a Figma mock to generated code, even 60% of the time, that's 60% of my time saved, mm-hmm. right? And so I actually think that the technology that we have right now, in the form of our LLMs, are enough to power those experiences, right? And so I'm super excited about Figma and their work over in AI, and I'm sure that they'll have some really, really good stuff for us very, very soon. And yeah, I think that's just the Figma to code generation process. Mm-hmm, mm-hmm. There's just so many different points in the design process that actually AI would be very, very helpful here. So things like, generative AI for, generating images, right? Generating sample text, right? These were things that you would have to do manually or reach out to a different API, but, this can now just all be handled by AI, right? And so features like that, which make it very, very easy to do a lot of the tedious work, are eliminated. I still think that we're still going to need tons of great designers, mm-hmm. Because as we talked about, design doesn't start in Figma. It's almost it's like pencil paper for jotting your ideas down into something and communicating that idea to someone else. I still think that design and just thinking about product obviously comes with a conversation, right? It's trying to solve that problem, and so I don't see that going anywhere soon. But in terms of just hey, well, once I have the problem, once I understand how I want to present that. How I want to like present that to the user. I mean, and that's where AI can come into play. You can generate tons of different possibilities and mockups that you might not have the time in the past to even explore. And so just like being able to generate tons of ideas and then just iterating through them much quicker than you're able to do will allow designers and engineers to be able to iterate on products way faster than they were able to do before. So that's what I'm most excited about, is just simply at the end of the day, like, product engineering is, you have a user that's having an issue, or you have an archetype of users that are having issues, and you want to be able to solve that. But it's very, very important to have a very tight user feedback loop. Mm-hmm. And so simply being able to iterate faster, such as by having these generative AI tools, will allow you to just close that loop and iterate, and ultimately get that human insight from the person that you're trying to solve the problem for, right? And just iterating on that quicker. Mm-hmm. So that's where I see
I mean, it'd be awesome if you could have the model auto-generate the UI, auto-deploy the AI, A/B test it, and then make a determination which one of these two features was better based off of behavioral metrics that are deterministic but are used in that feedback loop. I mean, something like that would be much better for when you're deploying for the millions. But when you're saying like, once you have clarity of thought of what a good design requires, the language model or Gen AI is very good at then taking that clarity of thought into the derived outputs of that. In this case, the derived outputs are going to be like the HTML, CSS, and React routes. But you having that clarity of thought is a prerequisite. But then saying, I could have multiple different derivations of that, each one with its own unique feature and some arguably rational decision for why it exists. Let's just deploy both out, A/B test it, and have the model automatically determine which one of those is better based off of the KPIs that you're trying to optimize for. And having that be like a feedback loop that just runs in a production system with some people that are overseeing it that'd be an awesome world to live in. So that'd be pretty exciting. But the one part on that I think is just generalizably true when using AI is when you're saying like a good designer isn't going away.
Yeah.
And maybe the developer that's transforming that code or the design into code, you might not need as many people doing that because that's work that's being automated. But what the designer there is doing is having a clarity of thought and a vision of what a problem or what a solution looks like, and then giving that to a model to then go and execute on that person's behalf. And that general statement of having clarity of thought and a clear solution outlined is a prerequisite of any great use casage of AI that I've seen so far. So like if you're a lawyer and you have a very clear train of thought and a clearly defined set of solutions with requirements, you could then use a language model that's been fine-tuned to effectively generate the legal document that has all of this. But it's not doing much ideation, it's just executing. Like when I tend to use it, like when I have a clarity of thought of a system and I can highlight in detail all of the specific requirements of that system and then give it specific outputs as like an architect or a designer, it then does a great job of actually generating maybe all the code specs, the Terraform documents, the different outputs of that. But the role of knowing what good looks like, having, like if you're in the art space, like you would say having taste and clarity of thought, that person, you can call them a designer, you can call them an architect, you can call them whatever you want. That is what the differentiator in any successful company or use case of AI is. And for the people that have that clarity of thought, that have that vision, that understand what good looks like and can clearly articulate a set of solutions, AI is just so incredibly empowering for that user base. And I would encourage everyone to think about, what do I understand a solution for with very granular detail and clarity of thought such that I can easily communicate it to a friend, to a colleague, to a coworker, and once I can find out what that problem is that I understand the solution for really well, I would really encourage that person to say, now how can I work with a language model to help me build a company around that solution, or build some system that I can then share with somebody else around that solution, because it enables people that have good ideas, can clearly articulate and communicate those ideas and understand the problem that those ideas solve, to be able to scale that very quickly. And if you're a great designer and you can articulate a problem very well alongside the solution and provide even a Figma document that very clearly communicates what the solution needs to be, like, AI is or at least will be in the near future, your best friend.
Yeah, 100% agree there. And I mean, I also thinking back to my experience, or over working for at Citadel, AI is great for just the sheer amount of data that's out there publicly, but a lot of some of these investment processes, they're not publicly available, right? A lot of the value and the alpha that is contained within the brains of people. Right. And they're not freely sharing that out on the web. And so let's say you're trying to solve, a problem, you can go to these, you can use an LLM to ask, like, hey, like, I want to organize, these tables of data in a way that's like not too visually jarring to my user. Right. That's great. I think LLMs will be perfect to do that, but it's not going to help you figure out, like, well, do they even want to see those pieces of data in the first place in the UI, right? Maybe they just want an email report of the updated numbers by the end of the week, and that's good enough for them, right? So, like, you don't want jumping to LLMs to just be a catch-all, right, for solving all of your problems. And just because you can output and a lot of things and you can execute on a lot of things doesn't necessarily mean that you're going to actually solve your problem. Like, you still have the same issue of figuring out, understanding your user, just talking to them, understanding their pain points. Like, that's not going to go away. So yeah.
Totally. Obviously, you don't think about just the front end. You've made a great point. It's really the full stack, from the data model, probably in a database, all the way to the end numbers that you should taking on a screen. Yeah. You can't think of UI in isolation, but when you think about more of like the nitty gritty problems that come with scalability, when a user says, "Oh, this is slow," what are some of the challenges and maybe any like tidbits of solutions that you think help with scalability and performance when it comes to the UI?
Yeah. So, yeah, typically when you get a report from a user, the only thing you're going to get is, this is slow.
Right.
Right. And it's one of the worst things to hear, because you have to dig into that issue. There's like so many different places in not only the overall technology stack, right? Because, but within, the browser itself, within your JavaScript, within the browser rendering engine, where you could be having these performance hiccups, right? And so, if you don't have enough data to, from the user to figure out exactly what's going on, you kind of have to start from the very basics, right? So, starting at the network request, right? It's like, is there something prohibitively large that you're trying to download just to display maybe a single number, right? And this is like similar to API design. If your API design is just constrained to simply give you back like an entire like 2 megabyte JSON blob, but all you need is like 2 metrics from it, right? Well, that's going to slow down your app, because every single time you want that little small number, you have to make this very expensive network request, right? And so that's just like one issue that you could have, is simply just on the data side. But then even going into the actual rendering, finance applications, for example, have a lot of different data points that they're trying to show on a single page. For example, if you think about the different types of charting that people need, grids and tables, which are often real time, these are UI elements that are updating, every second, probably even less than a second, depending on the requirements of your app. And then there's probably hundreds to thousands or even tens of thousands of data points that you need to plot or change, right? And so first off, does it even make sense for you to plot all of that data, right? Maybe even if you were to plot like 2,000 data points, the user's not going to be able to see that unless they like maybe zoom into the application, or maybe they filter into the grid, or maybe they start scrolling down, right? So you could have an issue just due to the sheer amount of data that you're trying to process and then put on the page. Then you could go into issues such as actual rendering. So, the browser itself has its own kind of rendering process, right? And as a developer, you only really have kind of coarse-grained controls of like how the browser actually handles rendering the actual pixels on your screen, right? And so, being able to diagnose whether or not this is a browser issue, whether or not this is a data issue, is this due to how your particular JavaScript framework is handling updates, right? So for React, one of the cons of React that people I've been seeing throughout the years is that it can become very unperformant if it's doing unnecessary renders, right? The way React works is that it has its own virtual implementation of the DOM, and it creates diffs of that DOM and the actual DOM each render cycle. And so you can imagine that if you're processing a table that has 10,000 cells, right, and it's doing that diff between 10,000 nodes every half a second, right, that can quickly add up to just simply you won't be able to see the data. Like everything will come to a crash, right? And so also understanding the technology that you're using, right, whether or not you're using React, whether or not you're using different frameworks that might not run into this problem, but they also have different problems. You really need to understand the entire kind of pipeline of data in from the network all the way into what does the browser paint at the pixel level. And so that's typically when I think about UI, it's like I'm making sure that you never have those issues, right? Especially in the context of applications where you need to have this data. It needs to be accurate and it needs to be real time because people are making very, very big decisions based on what they're seeing on your application. And I think those are the things that people who aren't as familiar with UI platform or UI engineering, they don't really realize that goes on under the hood. Typically, it's how does it look or how does it interact rather than how does it perform? How are we organizing the structure of like how are we actually getting the data from point A to point B within the front end? So
totally, it was real. I guess I hadn't thought about how React handles what to render, and that was a really interesting tidbit that I just got from that. That React has its own DOM, and then it does a diff across the elements and determines which one of these elements need to be injected into the page.
Yeah, and that's one of the reasons why it was just such a breath of fresh air when it came in. It was actually that was what was empowering the developer ergonomics of being actually able to write things like components. The previous frameworks such as Angular didn't really allow that. And so it's one of the features that actually powers and what makes React work. But at the same time, there is always going to be a trade-off that you need to make into that. And so now after React is pretty mature and people have been getting these issues more and more, and it's become one of the main criticisms of React. There's alternative frameworks that don't run into this issue and are a bit more performance. They don't always have to do things like re-renders and calculate diffs, things like Svelte. There's Solid.js, which is very similar to React, but it's just much more efficient in this way. And so like there's definitely been, I guess, people understand that this problem exists. But it's obviously difficult to move off of a framework which does get the job done if you use it right and properly, and if you understand the framework. But yeah, the React team actually has been working on addressing this issue. And they recently announced, it's very funny to say, but a React compiler. So basically, it's a pre-processing step. It's going to pre-process your React code such that it can do this diffing and more intelligently, such that you don't have as many re-renders. So it'll just make React more performant and hopefully solve this issue because otherwise it's becoming a pretty big bottleneck for people to continue to use React in ways that they want to if they always have to think about, is this going to cause bad performance? So yeah, once again, like the the ecosystem of JavaScript is always evolving, but they're evolving for usually the good reasons. There are just problems that come up as users start to use applications in more demanding ways, right?
We some of the interesting use cases that we've seen with AI within a lot of our clients is we'll have a lot of clients that'll look at names within a coverage universe or a watch list and then rank them on different dimensions. So you might rank them on the profitability of the different names, or like what is the management outlook, or what is the probability of a revision either up or down within this coverage universe. And then that becomes this essentially forced ranking system that might then turn into a buy signal or like a sell signal. And analysts spend a lot of time manually, like one, reading through all the research and then taking their domain expertise and quantify this forced rank system. And that actually is a great training set for a language model to then look at the analyst's forced rank system, all of the different data that they've reviewed, from sell-side research to what their Excel models were to what was going on within the news cycle or the company's earnings events, and then say, well, can we recreate a similar set of rankings on a new watch list, but using the same type of training models? And now you have one analyst that can only cover a relatively small universe of names in this forced ranking system, but now we can train off of that and have a language model start systematically looking at other names using the same inputs, but coming out with new forced ranking systems and having that generate like this is a really large buy, or like this is a small sell, or like we're kind of neutral on this name, and having a language model start training on top of that, which has been really cool. In the last episode, we actually talked to Kurt McEwen, and we spent a ton of time actually going through how you can really disrupt the expert network space, or how at least you ingest data from an expert network into a hedge fund research process. So expert networks are really popular for an analyst that's covering a variety of different names to be able to get on the phone with a doctor, or get on the phone with a roofing supplier, get on the phone with a lawyer, ask them very poignant questions about a ticker or what's some event that's going on with a supply chain, and then give a little bit more information to the analyst that they can't necessarily get by reading a paper or a document. But with transcription services, it makes it really easy to create structured text out of each one of these conversations. And if you already know ahead of time specific questions you're trying to answer, that the transformation of this unstructured conversation in an expert network call into a structured data set can happen automatically. So just by putting in every conversation you have throughout all these expert network calls into a set of LLMs that are trained on the way that you are already conducting research, and systematically start extracting out the pieces of data that matter from you from the conversation, has just been really powerful, because you can go from expert network call immediately into quantifiable data that is already part of my existing research process. Another really cool thing that we've been iterating on is taking unstructured research. Like, let's say we have a analyst note. Like, every time an analyst goes into an earnings event, there is research that they have to produce, maybe in a Word document or like in a Outlook email that they send off to their PM. And those are such treasure troves of training data. If you have a fund that's starting to systematically structure their unstructured research, and to start recreating that same type of research, given different inputs, but the transformation that the human being is doing, and try to start having an LLM replicate that. So we'll start by looking at, if we take like a research note that an analyst looks at, let's work with a client to get like 50 of these, as many of these as we can. They think these are good examples of research notes, and then pass that to a language model and saying, what is the meta structure of a good research note? And then can you help us take this unstructured document and turn that into a structured JSON object, where it's like, oh, well, there's clearly a thesis, but the thesis is usually composed of these 3 different meta components where they're discussing management quality, profitability, and supply chain quality. And so we just now, when we're going to construct theses in the future, we're going to make sure we hit on these 3 different data points. And then maybe there's another section where they're talking about EPS or subs, if it's a subscriber business, or margin. Like, oh, we need that as part of the inputs for a good research note. Well, for something like that, you can start looking, well, you can systematically pull that from the sell side. Let's just connect that to the Visible Alpha API. Or some other FactSet API, Bloomberg API, but we can systematically start ingesting that in. And maybe there is a counter argument or like a counter thesis. What's the structure of that? So using a language model to create very structured data on unstructured research outputs the team is doing is a great first step in saying, okay, now I at least have a model that if I can follow this structure and systematically start recreating this unstructured, I'm looking at a JSON document, I can start by pulling all of the data that I can find into these now really large context windows. We've been absolutely blown away with the quality of Gemini right now. And say like, hey, this is a history of exceptional research notes. This is the actual data structure that exists behind these research notes. And these are all of the different data sources that exist right now that you need to rely on to construct this research note. Put this data into this structured JSON object that kind of has everything, both qualitative and quantitative data, and now systematically start doing that for every name that I could possibly invest in. And then you go from analyst that is constructing research notes on maybe 40 like names per calendar year because they only have so much time, into an LLM that's just running on a batch process 24/7, 365, giving you almost as good research quality on thousands and thousands of potential names. And so your funnel of doing investment research just went for like the 40 different names that each one of our analysts can cover, and we have to hire 10 of them, so we can only do 400 names in depth, to 10x that with a fraction of the actual headcount. And then what you can start doing is like, hey, I want you to reconstruct the research every single day for each one of these 4,000 names. And then when something changes that the model determines to be significant, let's send a notification for the PM. And so now it's not perfect, but breaking down the unstructured research process into giving some structure that we can be deterministic around, and then scaling that really wide and throwing everything in the kitchen sink with the right context into some of these absolutely massive, large context windows, allow us to start automating the role of an analyst across thousands of names that nobody has the time to be able to like do all of that research. And then looking for day over day changes. And when there is a change the model determines that is significant, let's bubble that up to a human being to make a decision around. And that human being could be a senior analyst. It could just be directly the PM. And we say, all right, let's ignore it, not important. Or you can say, wow, that is actually quite interesting. Include citations for where the actual data source is indicating a change in some of that, into that research. And suddenly you're starting to do something that's very transformative. And that type of research could change whether it is a activist short selling fund or a long short equities shop focusing on maybe shorter term earnings events, or a long only deep research buy side fund that's trying to go really deep in each one of the names they cover. Like, we're starting, at least in my world, I'm starting to see a lot more use cases that are far beyond the default chats that everyone has. Because like ChatGPT came out with like their first iteration, it's like, oh, I can chat with an LLM. And everyone's imagination got really narrow and said, okay, well, let's just like print and repeat. So you would see hedge fund A /AI bot going to chat, hedge fund B /AI bot going to chat. And everyone then developing RAG models on top of the underlying APIs that are hitting for chat. So it's like, oh, I can search on all of my documents, which I think is actually really helpful in thinking through a chat interface in a way such that it also has access to your internal research via RAG interfaces is it's great. I think it's helpful, but I also think it's incredibly unimaginative of what you can actually use AI for. But I think in order to have a good imagination, you have to actually really understand the problems that your user base are trying to solve and understand that problem beyond just a surface layer, like truly internalize like the problems that the users that you're trying to develop for, and know that there's more solutions when using AI than just throwing a chat bot in front of them and hoping it solves everything. But that imagination requires domain expertise, requires people that are actually interested in the business of the problem space that they're trying to solve. And when you were originally saying that that's what brought you into UI and why you wanted to focus on what is the end interface for our users, because you want to understand what is the actual problem that they're trying to solve. So refreshing to hear and such an incredible perspective to have when thinking about what is the future of AI in the hedge fund asset management industry. So incredibly excited to see where you go from here, Brian. Love having you on the show. And with that, would like to say to everyone, thank you so much for joining in. Again, I'm your host, Michael Watson. This is the Hedgineer Podcast. We produce episodes every other Monday. Check us out on Instagram, LinkedIn, Twitter. Join the Slack channel. Come and say hi. We're looking at potentially doing some in real life events with maybe a mini conference or a happy hour for anybody that's interested in AI technology and data within this industry, trying to push the limits. So stay tuned to learn a little bit more about that soon. So till then, take it easy.
Thank you for joining. See you soon.
Hedgineer.